Welcome back, everyone. We are ready to start our next presentation, and our speaker is already on stage, as you can see, but it is my pleasure to introduce him properly to you. So, our speaker is Maciej Norberciak. Maciej works in Nokia, where he's primarily a software architect, but also a trainer and mentor. He holds a Ph.D. in computer science in the area of artificial intelligence, but has worked in the telecommunication industry basically forever, taking part in projects on various embedded platforms as a programmer, designer, and architect, as well as project manager. His favorite pastime activity is learning. Anything goes. Fun fact, he's a co-caretaker of a pure-breed, long-haired male breeder hamster. He already fathered dozens of beautiful pups. Before we begin with the presentation, please remember to use the conference application to rate every speech. And with a topic I might actually understand, being a non-technical person, software architecture in pictures, Maciej Norberciak.
I'm not sure I can promise anything about non-technical part. Anyway, I've been told by the organizers that the theme topic of this conference is back to the roots. So let's go back to the roots. Imagine you are a caveman or a cave woman, cave person, and you are sitting in a cave, obviously, 40, 50,000 years ago, and you are bored because you are on a boring clan conference or a tribe meeting, and you try to occupy your hands and mind and your eyes with something. So what you do? You doodle. You make a picture of a pig. Because we human beings just love making pictures. We do it for pleasure, to fight boredom. We doodle on small pieces of paper. Sometimes you use bigger canvas, like a side of a hill. Added bonus, your private parts are now visible from outer space. But we also do pictures to use them for something, for worship, for example, but also to describe something, to instruct, to make a description of a process. Of course, at some point, we invented writing. But, you know, writing is unexciting. It's sometimes ambiguous. We immediately found out that if a picture accompanies the writing, it tells 1,000 words. And it helps to get your idea across, to help to sell your idea. So after this talk, you may approach me, and if you give me 20 talents of gold, I will perform this procedure depicted on the papyrus herein upon your, departure of this earthly realm. And you will achieve life eternal. It's a great deal, really. I would love to peddle my funerary services for the next hour or so, but I promised the organizers this will be a talk about software engineering. Yeah, engineers. We software engineers take our humble roots in mechanical engineering. So pictures like that, and mechanical engineers were the people who gave us the first standardized process description in form of a picture, in form of a diagram. Let's make a rifle grenade. Rifle grenades are things like that. You put those things into this, and you make other things go kaboom. By the way, we don't make those anymore like that. If you want to shoot a grenade from a rifle, you don't put the launcher on the barrel, you put it underneath the barrel. In 1921, two mechanical engineers, a pair, Frank and Lilian Gilbert, proposed a process description. They called it a process chart. This was the first flow chart ever. This was a description of a process of making rifle grenades. There's a fragment here, and the whole thing was much longer. When I was researching it, fun fact, Lilian was not only a brilliant mechanical engineer, she's actually more famous as a psychologist. And Frank and Lilian had 12 children between them. My experience as a parent is that they probably never slept, but then someone told me about wet nurses, so yeah, that's that. We needed to wait around quarter of a century for the flowchart to make their way into IT industry, because there was no IT industry in 1921. But we, software engineers, we don't make material things like grenades, we make things that are more ephemeral, like peas. So this is a pea we'll be making today. There's a mathematical formula for this pea, and this is the first flowchart ever in computer science, an algorithm to make a pea inside an early computer. This was proposed by founders of computer science, Hermann Goldstine and John von Neumann, 1947. Fun fact, they met a couple of years earlier by a complete chance on a railway platform. Von Neumann was working back then for a Manhattan project, and Hermann Goldstine was freshly married to a fine young lady called Adele. Adele Goldstine, prima voto Katz, was a computer programmer. So yeah, women in IT from the very beginning, in the roots. Okay, but this is not something that comes to your mind when you hear the word flowchart. You think rather about pictures like that. This is more or less a flowchart according to ANSI ISO standard. Standard comes from 1960s, but it is very current, very much in use. The last revision was in 2019, so it's fresh. This way of making architectural pictures, in general pictures in computer science, was also my first flowchart. I got this book when I was 10, Atari Basic for Children. Before this book taught me how to program my 8-bit computer. It taught me how to put an algorithm into a form of a picture, a drawing, a diagram. My first algorithm was how to scare my mom with an elephant. Yeah, and we are 6 minutes in, and you should start asking yourselves, hey, where is this software architecture I was promised? Well, I will give you a standard definition because I don't like things to be nebulous, and this, when I talk about software architecture, there's always this fight, what is software architecture and what isn't, what's software architecture, what's design. Standard definition comes, well, from the standard, ANSI IEEE, and it says that this is depiction of the system in terms of its building blocks, so components, subsystems, what have you, their interactions, connections between them, and it's also principles governing its design and evolution, so how you will work on the system in the future. And here another fight about terms comes because there is this argument, what's design and what's architecture, where design stops and architecture starts. So for the purpose of this talk, we will assume that software architecture is about those big building blocks, components, subsystems, whatnot. And design is what's inside those building blocks, how they are implemented. That would be simple enough. So how is this diagram an architectural diagram or a design diagram? Well, depends on how this translates into a finished system. So if you translate this algorithm directly into a source code of some sorts, this would be a design diagram. But if it's a depiction of a bigger system, which has bigger building blocks, like an elephant acquisition subsystem and elephant hiding subsystem, that would be already an architectural diagram. Why we do those? Well, I do it for money. I'm a software architect, so they pay me for doing things like that. But there is, of course, apart from this ulterior motive, something else behind. You see, inventing architecture in your head is just the first step of my work. Then I have to create it. And by creating, we usually mean preserve, so put it in some permanent form, because we need to communicate it. And we communicate it to our stakeholders. And some of just to help them do their works, do their jobs properly. And some of those stakeholders are people who are actually taking your architectural description, so not only diagrams, but diagrams among others, and they decide based on requirements, constraints, and business goals whether to give you money for implementation of this system, whether to fund your ideas. Actually, we architects also make decisions based on business goals, constraints, and requirements, just on a different level. We make those decisions, we communicate them, and usually somewhere in between, the documentation happens. We preserve those decisions in some form. And this documentation actually is useful for many different things. First and foremost, if you are from the agile background, you will say that, well, good clean code is a best way to document things. Yes, of course. But if your code base is 7 million lines, and the oldest of those lines come from 1990s, and they were written by someone who thought himself a rockstar programmer, well, it's not manageable. And for managers, it's completely unmanageable because usually they don't read code at all. They don't want to, and they simply can't. So yes, we use documentation to manage the complexity because it makes, first and foremost, our design implementation easier if you have a good, proper architectural documentation. Then you can predict quality attributes of your future systems before implementing anything. Quality attributes like maintainability, security, performance, things like that. With proper documentation, make your job as an educator of new team members easier. Well, of course, they can read the source code, right? But in order to see the big picture of those 7 million lines of codes, it would be easier just to read the documentation. Then for managers, it's a fantastic tool because they see, oh, here's a component A, so I can assign team A to component A and team B to component B. Being a manager is fairly easy, I would say. When something inevitably goes wrong in your work, you will use this documentation to prove that, first, this is not your fault, and you can shift the blame to someone else. Yeah, well, I'm kidding, of course, but investigations when something goes bad are easier if you have a good comprehensive documentation. You have to think about architectural documentation as a time capsule. Love letter you send to either your future self or future architects of your project, because in 2 days, 2 weeks, for sure in 2 months, you will not remember why have you made this particular decision in this particular way, why something was implemented in particular way. So it helps with archaeology, and added bonus, you will make all those agile zealots unhappy because they prefer working code over comprehensive documentation, and we will go back to them in a moment. But of course, there is no free lunch, and with documentation, especially with diagrams, come some problems. Actually, they are not technical, they are psychological, I would say, because we human beings tend to love our creations too much. We form this bond, this attachment with the things we create. And the strength of this bond is proportional to the amount of work we put in our creations. If you look at the documentation in form of a, textual documentation, okay, surely this took a lot of work to write, but this page is, boring, uninspiring, not exciting. A diagram, the diagram is beautiful and exciting and inspiring, and you will fight to the death for the idea depicted on this diagram, even if it's utterly stupid. You will die on that hill. That is called irrational artifact attachment, and this is a phenomenon we can fight with. My recommendation is to start documentation with something fleeting, ephemeral, non-permanent, like a flip chart or a whiteboard. But beware, do not put those sticky notes, post-its with "do not wipe" on them, because it will turn on you. You will make those things permanent. I remember when I was still working at the office, every day I was walking through open space and I was passing those whiteboards left and right, and they all had those "do not wipe" notes on them, and I was passing the same diagrams for several years. So don't do it. The time for beautiful pictures, beautiful diagrams will come, because you will need to create them for your managers anyway, at some point. Okay, coming back to the history, we started with flowchart. Flowchart is called a classical diagramming method among other classical diagramming methods that were used not only for software engineering, but also for other engineering stuff, or even for business processes. We have CFD, control flow diagram. The name is self-explanatory. This depicts the flow of control in a system. If you Google it, you will end up all the time with this F-16 fighter jet plane flight control system. The whole article is freely available. I think it's all fake, just to confuse the Russians. FFBD, functional flow block diagram, is another classical diagramming method. This functional here has little to do with functional programming. This pertains to the flow of functions. So if you have an arrow between boxes, that means that one function precedes the other. And it can be multi-level, multi-tier. This fragment here is how the space shuttle missions were planned. And by the way, if you Google for NASA system engineering handbooks, all the revisions are freely available online. Look for those old ones in order to see old diagramming methods. Those methods, those diagrams were created in 1950s, more or less. In 1970s, something that is actually aimed at software engineering came, data flow diagrams. And this was a part of a set of methodologies called structured analysis or structured design. And there were more diagrams coming with those methodologies. Context diagrams, which depicted the entirety of the system, the big picture, high level, actors interacting the system. Entity relationship diagrams, this thing on the right, they are still very much in use. And actually, what you see here is the same thing depicted in 6 different ways. Depending on your point of view, there were either a bunch of informal methods or a bunch of standards, but not a single standard, just a bunch of competing standards. There were other things like data dictionaries, process specifications, and again, this was not really standardized. Process specification could be in structured English, it could be a flowchart, it could be finally just a pseudocode. Something needed to happen before we got one true and only way of depicting software architecture. But before we get to that, let's talk about another set of problems with diagrams. Problems coming from, again, from psychology, but exemplified by those informal methods. You see, this set of problems comes from the, well, people like you, the audience. We have many recipients of our diagrams, many stakeholders, people who hold stakes in our projects. So fellow architects, developers, testers, security specialists, sometimes customers, users, of course managers, always. And for every audience, you need different detail level, different abstraction level, different view, different perspective. When you change view or change perspective, you need to maintain so-called coherence of representation, so you don't confuse your audience. You need to make sure that your message, your diagram, is understood by your audience. That makes architectural diagramming not only a hard technical skill, but also, or maybe first and foremost, a people skill, a soft skill. Let's make an exercise, okay? What is it? Anyone? Database, yes, great. But I would argue that this is a better database. It can be any type of storage, actually. But I can always say that this is not a database, it's a drum. I mean, drum. Or an oil drum, right? There's a put oil drum, actually, because all oil drums have those oil drummy thingies on top, right? But even if I hide this oil drummy thingy, it will still be an oil drum, right? Or a database, or a drum, or IKEA Kühlen. Of course, this is an artificial example. And if you see a software engineering diagram and you see such a symbol, you will probably, unless you are a manager, you will not think about IKEA Kühlen, you will think about the database or storage or something similar. But this is a problem with informal notations. Your diagrams, your box and arrows have to be understood by every member of your audience exactly in the same way. And we human beings, we have problems with interpretation, you know? People fought wars about interpretations of some words or symbols. This thing I've mentioned, the thing that had to happen before we got our first universal way of thinking and depicting software architecture was object-oriented world. So this was not a new idea. Languages that supported object-oriented programming paradigm were already there in 1960s. But in 1985, the best language in the world, and don't even try to argue with me, was created, C++. And with that, this started a revolution. Old languages got support for object-oriented paradigm. New languages that supported object-oriented paradigm from the get-go started to pop up. And of course, everybody went on board with this idea. In 1989, something called Object Management Group was created. This was a consortium of big hitters back then, you know, HP, Apple, IBM. They wanted to unify the way we describe object-oriented world, the way we use object-oriented methodologies. Quietly, in 1981, a small company called Rational Machines was created, and they changed their name in 1994 to something that may be more famous or known to you, Rational Software. They employed a bunch of brilliant engineers. And those engineers started to work on a secret interbreeding program. They want to crossbreed Godzilla with everything everywhere all at once. And they succeeded. They created UML, Unified Modeling Language. It is a behemoth. It is gigantic, like Godzilla, and it truly aims to depict everything, everywhere, all at once. Both architecture and design on all the levels, in every possible aspect and perspective and view. There are, it's a good thing you are sitting, 14 different diagram types in UML standard. They are classified as either as structural diagrams, so static ones depicting the structure of the system, and dynamic ones, behavioral diagrams, which depict the behavior of the system. So I will quickly browse through them. Bear with me. Structural diagrams. We have class and object diagrams, of course, because this is object-oriented methodology. Then package diagrams, component diagrams, deployment diagrams, composite structure diagrams, and profile diagrams. On the behavioral side, we have use case diagram, sequence diagram, activity diagram, state machine diagram, communication diagram, timing diagram, and interaction diagram. Wow! UML has steamrolled the entire ecosystem of object-oriented methodologies. Look at this. This is a timeline I've taken from Wikipedia. Before UML, there were an entire zoo of different methods. And when UML came out, they all converged into one. Well, almost all of them at least. And the best thing about this was that things that came after UML were UML2, because there is this profile mechanism built in the UML, and you can extend UML with non-standard additions. So languages like SysML and SOML and Marty and UML testing profile, they were all, in essence, also UML. Yeah, with one exception, BPMN was not UML, but well, BPMN is business process description language. So what has happened exemplifies the problems we have with formal notations. Well, first and foremost, does everyone in the room knows UML? Because you need UML in order to understand our diagrams. Okay, who of you knows UML? Ooh, roughly half of you. Huh? Okay, does everyone understand finer points of UML? For example, there are 13 different types of connections in UML. Huh? Do you know them all? And those are just arrows. There are boxes, you know, circles, and other syntactic elements in UML. But this is not the core of the problem. You see, the core of the problem is that people started arguing, is UML really a formal language? You get a bunch of graphical elements, right? And the ways of connecting them together in a proper way. This is called syntax. So if you put a diagram of a system together and you want to verify whether this system is correct, you can do it just on a syntactic level. In order to do it on the semantic level, so if you want to see whether the system will behave properly, you would need a formal definition of semantic properties. But UML does not have this. In order to have a proper definition of semantic properties, you need to do it in a formal way, right? And by formal, I mean mathematic or logic or something like that. There was this addition to UML called OCL, Object Constraint Language, but it was purely academic. It never left academia and invited the industry the way UML had. So you have this notation, you can't do anything with that. There are languages, architectural description languages, that do the proper semantic definition. Ironically, they are called architecture description languages. And they are used, but they are used in a niche. Things like highly reliable embedded systems, automotive. I'm not saying that this is a small niche, but the niche, nevertheless. Most of the people just use UML. The problem with those diagrams is that they do not compile. You see, when you doodle something on a flip chart or whiteboard, well, this paper or flip chart will accept anything, right? If you start drawing something in a tool, usually in order to make those beautiful pictures, you need a proper tool. The tool will accept almost everything. Of course, there are some built-in constraints and checks, and tool will not allow you to do something that is that the tool interprets as against the standard. But you can abuse the tool or misuse it. You can put a textual note. There is an element in UML, a textual note. Those are not the droids you are looking for. Or you can export this picture into a bitmap and edit it in Paint. Why not? Yeah. Your diagram will not compile anyway. You will not be able to generate code from this diagram anyway. Of course, with some exceptions, because from those architectural description languages, usually there is this feature to generate code, proper working code. There are also graphical modeling languages that allow you to do it. Things like Simulink or LabVIEW. But again, this is a niche. not industry-wide method. And this was the biggest promise that UML advertised, and this was the promise that UML couldn't deliver. And the reason for that was very simple. You see, if your diagram is to be useful, and by useful I mean to communicate something, to solve a problem, to understand the problem, it has to be a simplification. A simplification is something that omits all the unnecessary implementation details. And if you don't have implementation details, you will not be able to generate implementation from that, right? It's obvious when you look at this from that perspective, but you know, hindsight is always 2020. People in 1990s couldn't realize this simple fact. If you want to generate code from a diagram, it has to be full of details. And this is not really a good example, because there are not enough details in this diagram to generate code better than a boilerplate for those classes. Make a reverse engineering exercise, if you will, at home. Take your code, put it into a diagram. It can be done automatically. And then look at this diagram. If it allows you to do the same thing in reverse, so generate the code, it will be full of details, and it will be no better in readability or usefulness than the source code itself. But if you want to have just a proper, beautiful picture that shows you the structure of this code or some properties of this code, it will be a simplification. You will not be able to generate code from that. So yeah, people were disappointed with UML. And just 4 years after the first version of UML was released, people started to rebel. Well, this was not this rebellion. This was in 1977. I'm talking about this 2001 rebellion. People found out that, oh, UML is large and complicated. And people who graduate from universities, because every single university in the world taught UML back then. I started studying computer science in 1997. UML was big. I had 3 semesters of UML, hundreds of hours. Lectures, exercises, we did all the projects in UML. But after you graduate, you start to forget all those 14 diagram types and 13 types of arrows and boxes and circles and whatnots. And you came to the company and, yeah, you know UML? Yeah, kind of. People also realized back then that waterfall doesn't work. Waterfall was this funny way of doing software. You started with analysis of requirements, then you did a big upfront design in UML, of course. And after you had all the design work done, you started implementation. Yeah, this doesn't work because we found out that work on software is iterative. You have to come back to analysis, to design, implement, test, come back to the drawing board. People realize that upfront design is stupid. Well, not having upfront design is even more stupid, but still, they started to rebel and they issued this manifesto of agile software development. And there is one particularly heretical thing about it, because it says that we prefer working code over comprehensive documentation. And agile methods started to proliferate, and people started to abandon UML. And just after a few years, since 2004, the popularity of UML goes down steadily. The object-oriented group who is custodian of UML standard, tries to push it. They issued UML 2.0, then 2.5. They tried to sell it to other industries apart from software, even retail. But well, we burned those bridges, unfortunately. But we still needed pictures. We still need pictures all the time. So after UML, things started popping up that were not UML or UML profiles, and just two of them gained some traction. First is called Archimate. This work was done between 2002 and 2004 by a consortium of Dutch companies and academia, sponsored in part by Dutch government. This is not a really architecture description language, but rather an enterprise description language. This is actually quite clever because they want to describe in this language not only software, but also the business processes, and you can show both the active and passive parts on the same diagram. This is not really software-centric, but rather business-centric. Of course, you could do all the software, or you can do all the software in Archimate, but you can't do design, because on the lowest level there is an object, but there is no concept of class. You can do different types of diagrams in Archimate. This is so-called generic diagram, and this is actually everything, everywhere, all at once, on all three levels defined in Archimate. The highest level is business level, then you have the middle level, the application level, and on lowest level you have a technology level. And this upper level, this business level, is not software. You can do the diagrams that show just one level, like this example of application diagram, or this example of technology diagram, but you can do them from different views and perspectives. This is a built-in mechanism in this language, but they do not aim to do everything that UML did. They aim to cover 80% of the cases. And what you do in the rest of those 20%, well, probably UML in a way. Another thing that gained some traction is C4. This is the invention of a guy called Simon Brown. It looks like that. Not Simon, just C4 notation, or actually it doesn't look like that, because it's so simple that Simon does not propose any notation. This is a set of elements you can use, but you can use something different if you like. He's a software architect, and he was doing a lot of trainings. And one part of those trainings were giving people some requirements, asking them to translate them into a system, and then communicate this system. Of course, people have chosen drawings, and they struggled with those drawings because people coming from Agile world do not really like using UML. They shun UML, but they don't have anything else, and this was always a disaster. So he proposed this simple idea to show a picture on 4 different levels, hence C4: context, container, component, and code. Actually, this 4th level, code level, the lowest level of systems structure, is optional. And Simon does not propose anything for this lowest level. He says, use anything you like. It can be a source code, but it can be UML. So you will end up with some UML anyway. So what to do? What would be my advice as an old architect to all you fine people who need pictures? Well, first, do not overthink it, because it will kill you. If I can make a recommendation, learn some UML basics. There are some useful things in UML, just fewer and far between. I remember I was working at a company that decided to use UML because the code base was large and complicated, and we wanted to do it reasonably. We chosen just a fraction of diagram types and just a fraction of semantic elements to use on those diagrams, and we have written a handbook how to use them properly and sensibly, and this was 250 pages. So, yeah. There are some useful things in UML. Even on informal diagrams, you will see elements of UML, like like classes. Almost everyone writes the picture of the class in the same way, and it is UML-ish. But you will learn something that is used by your company anyway, and pray that something is used in your company if they don't have any formality or any way of doing pictures besides, you know, oral history passed from architect to architect. Try C4 for doodling apps, for depicting small things. It's fine, and your management will love it because it's so clean and simple and easy to understand. And practice, practice, practice. Find some architectural exercises. Katas, they are called katas. It's a description of the system in textual form. You have to translate it into a picture and then show it to someone. See whether this someone understands this picture in the same way you do. All right, that brings us to the end of my talk. If you want to know more, or maybe in more organized manner, I've written an article for Programista magazine. If you read in Polish, you should read Programista magazine. This is the last edition. It should be still on the newsstands. The next edition comes in just a couple of days, so hurry if you are not a subscriber. Thank you very much for your attention. I can take some questions now.
Okay, so do we have any questions?
No takers.
Thank you, Maciej, for your talk. Maybe I will ask about working on documentation with Agile, because you are laughing a lot of this on your presentation. But the problem with the standard documentation is that sometimes there is how to say, made in stone, and you cannot change anything. And if you are experienced software architect, actually, when you have some changes during the implementation, or maybe some clients want to change something, how do you approach this without using the agile technology or manifest? So.
Okay, I don't want to be misunderstood. Agile is fine, and software architecture is agile. Agile is built in the software architecture because you need to evolve your architecture all the time. Every single architectural decision you make in time will be wrong because the world moves on. The technology is evolving all the time. The systems we are working on evolve all the time. There are new methods and so on. You have to be flexible. So yeah, agile in your thinking about architecture. And I don't see a documentation as something written in stone. You have to change something, make a revision, make a review of this revision. And the worst thing that can happen about your documentation, diagrams or not, is that the things that are in this are not current. The non-existent diagram is better than a diagram that lies. So yeah, just make an update. It's not a problem. It's not like the fact that we are doing architecture and we are doing some of the work beforehand, it's not contradictory to using agile methods. I need to make a talk about it.
Okay, I think we have time for one more question. Looks like it was pretty clear. We have no questions. So thank you very much, and give it up for Maciej.